Let's see our next inequality. We have 3 absolute values. So it means we have to consider 6 cases. For each absolute value, we will have 2 cases. For whatever is between absolute value bars greater than 0 or equal 0, and whatever is between absolute value bars less than 0. Let's first calculate the intervals for which we have to solve this inequality. First, we have between absolute value bars 2x minus 1. So first we check when 2x minus 1 is greater than or equal 0. Next, 2x minus 1 less than 0. The same we have to do for the rest absolute values. So we have 4 minus x greater than or equal 0 and 4 minus x less than 0. And the last absolute value is x plus 3 is greater than or equal 0 and x plus 3 less than 0. Let's solve these inequalities. So we have 2x is greater than or equal 1. I will divide both sides by 2, so we will have x is greater than or equal 1/2. The same here, I will move negative 1 to the right side, so we have 2x is less than 1. I will divide both sides by 2, so x is less than 1/2. I will move 4 to the right side, so we have negative x is greater than or equal negative 4. I will divide both sides by negative 1, so we have x, and because I divide both sides by negative 1, I have to change the direction of our inequality, so it will be x is less than or equal 4. So the same we have to do here. We have minus x is less than negative 4. So I divide by negative 1 both sides. So we have x is greater than 4. And we have x is greater than or equal negative 3. And x is less than negative 3. Now we have to put this solution on our number line x. First I will put these numbers. We have 1/2, 4 and negative 3. So first will be negative 3, 1/2 and 4. So let me use the colors. We have first x is greater than or equal 1/2. Greater or equal, it means 1/2 is included. And value greater we have on the right side of our 1/2. This part is for 2x minus 1 greater than or equal 0. And the value x less than 1/2 we have on the left side of our 1/2. And this part is for 2x minus 1 less than 0. Next, we have to do the same for the next inequalities. We have x is less than or equal 4. So it means 4 is included. Value less we have on the left side of our 4. This part is for 4 minus x greater than or equal 0. And x greater than 4 is for 4 minus x less than 0. And what else? We have x is greater than or equal negative 3. So negative 3 is included. Value greater we have on the right side. This is for x plus 3 greater than or equal 0. And on the left side we have value for x plus 3 less than 0. And I forgot to put this number is not included. And the same will be for 4 and for 1/2. We see that we divide our number line into 4 intervals. It means we have to solve our inequality for 4 cases. First will be from negative infinity to negative 3. Next is from negative 3 to 1/2. Third interval will be from 1/2 to 4. And the last interval is from 4 to positive infinity. So now we will solve our inequality in the first interval. It will be our first case from negative infinity to negative 3. This is open interval. In this interval, we see that 2x minus 1 is less than 0. So let me write x minus 1 is less than 0. 4 minus x is positive, and x plus 3 is less than 0. So now when we know that 2x minus 1 is less than 0, based on our definition of absolute value, when we take this absolute value bars, we have to put negative sign before this whole expression. So we will have absolute value of 2x minus 1 will be equal, we have to put negative sign, and in parentheses we will have 2x minus 1. So we have to change the sign inside this parenthesis, so will be negative 2x, and negative give me positive 1. Absolute value of 4 minus x, because this expression is positive, so it means when we take this absolute value bars, we just have to copy wherever is between these bars. So we have 4 minus x. And third absolute value from x plus 3, again, is less than 0. It means we have to put negative sign before this whole expression inside absolute value bars. So it will be negative x plus 3 in parentheses. So we have to change the sign. It will be negative x minus 3. Now we can copy our inequality. So we have absolute value of 2x minus 1 is less than or equal absolute value of 4 minus x plus absolute value of x plus 3. Absolute value of 2x minus 1 is equal negative 2x plus 1. We have to copy our inequality sign, and absolute value of 4 minus x is 4 minus x, and absolute value of x plus 3 is negative x and negative 3. Now we have to organize these inequalities. I will move expression with x to the left side, so it will be negative 2x plus x is less than or equal. We have 4 minus 3 is 1, and I will move positive 1 to the right side, so it will be negative 1. Negative 2x plus x is 0. 0 is less than or equal. 1 minus 1 is 0. 0 is equal 0. So it means our inequality is always true. for all real numbers. But we cannot forget that we solve this inequality only in this interval. So it means the solution for the first case will be interval from negative infinity to negative 3. This is our solution to the first case. Now we have second case. We have to solve our inequality in interval from negative 3, close on the left side, to 1/2, open on 1/2. Let me copy this. We have from negative 3 to 1/2. So let's see our interval. In this interval, we see that 2x minus 1 is less than 0. 4 minus x is greater than 0. And x plus 3 is greater or equal 0. So let me copy this. We have 2x minus 1 is less than 0. 4 minus x is greater than 0. And x plus 3 is greater than or equal 0. So it means our first absolute value from 2x minus 1, because it's negative value, it means we have to put a negative sign before this whole expression in parentheses. So negative 2x minus 1. This is equal negative 2x plus 1. Now we have to take absolute value of 4 minus x. This expression is positive. It means we just copy 4 minus x. And the third absolute value from x plus 3 is greater than or equals 0. It means it's positive. So it will be just x plus 3. So we have absolute value of 2x minus 1 is less than or equal absolute value of 4 minus x plus absolute value of x plus 3. Now we know that absolute value of 2x minus 1 is equal negative 2x plus 1 in this case is less than or equal absolute value of 4 minus x is 4 minus x, and absolute value of x plus 3 is x plus 3. So we see negative x plus x will cancel, and we have negative 2x is less than or equal 4 plus 3 is 7, and when I move positive 1 to the right side will be negative 1. So negative 2x is less than or equal 7 minus 1 is 6. Now I will divide both sides our inequality by negative 2. Negative 2 and negative 2 will cancel, and we have only x, and we cannot forget when we divide or multiply by negative numbers in inequalities, we have to change the direction of our inequality. So it will be x is greater than or equal 3, negative 3 of course. So now let me draw this interval. Will be x must be greater than or equals negative 3. So it means we are going to positive infinity, and we cannot forget about our domain. We solve our inequality in interval from negative 3 to 1/2, close on the negative 3. So it means we have interval close on the left side to 1/2. On 1/2 we have open interval. So we have to put together these two intervals, and we have solution for the second case. It will be interval from -3 to 1/2, open on the right side. Now we have the third case for interval from 1/2 to 4, close on both sides. In this interval, we have 2x minus 1 greater than or equal 0. Let me write this. It's greater than or equal 0. Next, we have 4 minus x is greater than or equal 0. And x plus 3 in this interval is positive. So absolute value of 2x minus 1, because we have value greater, so when we get rid of absolute value bars, we have 2x minus 1. Absolute value of 4 minus x is also positive, so we just have 4 minus x. And absolute value of x plus 3, because it's also positive, it means we just get rid of absolute value bars and we copy whatever is between absolute value bars. Now we have to write our inequality. We have absolute value 2x minus 1 is less than or equal absolute value of 4 minus x plus absolute value of x plus 3. For absolute value of 2x minus 1, we just put 2x minus 1 is less than or equal absolute value of 4 minus x is 4 minus x, and absolute value of x plus 3 is x plus 3. So negative x, positive x will cancel, and we have 2x is less than or equal 4 plus 3 is 7 plus 1, so 2x is less than or equal 8. I will divide both sides by 2. 2 and 2 will cancel, and we have x is less than or equal 4. Now we have to draw number line. We have 4. 4 is included. Value less we have on the left side of 4. And now we have to also include our domain. It was from 1/2. 1/2 is less than 4. We have interval close on 1/2 to 4. So we see our solution will be in interval from 1/2 to 4. Let's go to 4 case. 4 case we have in interval from 4 to positive infinity. In this interval we have to solve our inequality. In this part we see that 2x minus 1 has value greater than 0. So let me write this. 2x minus 1 is greater than 0. Now we see that 4 minus x is less than 0. And x plus 3 has value greater than 0 in this interval. So now we have absolute value of 2x minus 1 will be 2x minus 1. Because 2x minus 1 is positive, it means we have to just rewrite whatever is between absolute value bars. for absolute value of 4 minus x, because we have value less than 0, it means we have to put negative sign. So we have 4 minus x, and we have to change the sign, so it will be negative 4 plus x. And for absolute value of x plus 3, we have positive value, it means we have just x plus 3. Now we have to just copy our inequality. We have absolute value of 2x minus 1 is less than or equal absolute value of 4 minus x plus absolute value of x plus 3. Absolute value of 2x minus 1 is 2x minus 1 is less than or equal absolute value of 4 minus x. We have to put negative 4 plus x, and absolute value of x plus 3 is x plus 3. So we have 2x, x plus x is 2x. I will move to the left side, so it will be negative 2x is less than or equal negative 4 plus 3 is negative 1, and negative 1 we will move to the right side, so it will be plus 1. 2x minus 2x is 0. 0 is less than or equals 0. This inequality is always true for all real numbers, so it means the solution for the fourth case is all real numbers in this interval. So we have solution for the fourth case. Now we have to put together these four cases. From the first case we have solution from negative infinity to negative 3. From the second we have interval from negative 3 to 1/2, close on the left side. From the third case we have interval close of both sides from 1/2 to 4. And from the fourth case we have interval from 4 to positive infinity. So we see these four intervals give us all real numbers. So the solution for this inequality is all real numbers.